Hello, so today we are going to learn about stoichiometry and actually how to do this and how to do conversions from mole to mass to particles, and we're going to pull in all the concepts that we learned together about molar mass and using these tiny numbers on the periodic table, and also this periodic table is used for a reference. Anyway, so right here I have a diagram to help you guys convert from particles to moles and moles to grams. So particles to moles, it is Avogadro's constant right here, 6.022 times 10 to the power of 23, while for moles to grams is molar mass. So if quick little refresher, molar mass are the tiny numbers, once again written on the periodic table right here. And to find the molar mass of a compound, you simply add the molar masses of its components, which are the elements on the periodic table. So we have this diagram right here, and we can do a quick little example to learn how to use this conversion diagram right here. So the question is, convert 7.41 times 10 to the power of 24 molecules of C2H2 to grams. So we are trying to go from the number of particles, which in this case is molecules, and to the number of grams right here. So I will be using the railroad method. For those that don't know the railroad method, it's the idea of drawing a horizontal line and little tracks right here where you write in the conversions, and at the end you multiply all of these and you divide all of these, and that should give you the number. It is definitely a very simple method, and if you know how to set it up correctly, then doing stoichiometry is extremely easy, and it is not as intimidating. And I can teach you how to set it up. So 7.41 times 10 to the power of 24. It is given in the question, so I am going to go ahead and write this out. Oops, molecules. I'm going to go ahead and write this out, and it is important to put in our units because that is also going to tell us if our units are correct by the end of it and if we did our conversions properly. So we have 7.41 times 10 to the power of 24 molecules of C2H2. But in that many molecules, in 1 mole of C2H2, let me write it out, 1 mole of C2H2, we have 6.022 times 10 to the power of 23 molecules of C2H2. Now, where did I get this? Once again, this is Avogadro's constant right here, and it is also seen in our diagram. Oh, let me draw that again. It's also seen through in our diagram because we're trying to go from the number of particles to the number of moles, so we divide right here. So that makes complete sense, right? Because our Avogadro's constant is in the denominator. Alrighty, so we have the number of moles. Now, for 1 mole of C2H2, how many grams of C2H2 is there? And that is the molar mass. So we are multiplying this way once again. The molar mass. The molar mass of C2H2 is 26.0378 grams per mole. Let's not forget units once again. And I'm just going to write C2H2 just as a note to self. And then we put this into our calculator. Now, I mentioned how putting in the units will tell us if we actually answer the question or not, which it makes complete sense because the units cancel out. For example, molecules cancel out, mole cancel out, and that just leaves grams out. This mole right here also gets canceled out because this mole right here, but it makes sense, right? Because this allows you to keep all of your units in check. Anyway, so once you go in and you multiply this entire numerator and multiply this entire denominator and then divide the numerator by the denominator, you should get about 320 grams of C2H2. So in normal words, in this many molecules of this fancy looking compound, so many grams exist. And this is the beauty of stoichiometry. We can convert things that might seem a little scary at first. Okay, now that is the basic gist of using this diagram right here and how to convert and how to use it and how to, once again, set up the railroad track. Another thing to mention is I mentioned how the units also cancel out, but that great check is to see if these units even line up. So if the yellow units line up, or if the cyan units line up right here. So it needs to go this way to visually help you guys. Just like that. Okay, so we know how to use a diagram. That's pretty simple. That's mindless work, but let's add some more complexity to it. Let's add in the idea of mole ratio. So we're going to use the answer that we got last time. So we were going to convert 320 grams of C2H2 to grams of hydrogen. So how much of hydrogen is in that in 320 grams of this compound? Now, I mentioned mole ratios. So what even are mole ratios, right? So let's move off to the side right here and let's talk about mole ratios, right? So mole ratios are pretty simple. For example, if I have 3, 4, 5 circles right here, and each of these and each of these 5 circles have, like, is this blonde hair? I don't know. Let's pretend it has blonde hair. So each of these circles have blonde hair, and if I'm trying blonde pigtails, these are pigtails. So if I'm trying to calculate the number of pigtails on all of these circles, instead of going in and counting 1, 2, 3, like that, that's too time consuming, especially in chemistry when it comes to atoms and we can't even see the atoms. So when it comes to chemistry, we simply use ratios. So we know we have 5 circles, and we have 2 pigtails per circle. So we have 2 pigtails per circle. So we simply do 5 times 2, and that will give you 10 pigtails. And that essentially means that we use a mole ratio. So similarly, we have 5 moles of circles and 2 moles of pigtails per circle. So when you do 5 times 2, that will give you 10 moles of pigtails. So similarly, more relevant to our example, instead of circles and pigtails and blonde hair, who knows, we are going to use this in chemistry. So we know that for 1 mole of C2H2, there are 2 moles of carbon and 2 moles of hydrogen. And this is mole ratios. Okay, now going back to the actual question right here, we are going to use stoichiometry and once again the railroad method. So we have 320 grams of C2H2. Those are the number of grams. Horizontal line. You have 320 grams of C2H2, but we want to convert this into moles because once again, this is called mole ratios, not gram ratios, it's mole ratios. So to go back here, to convert from grams to moles, this way, we divide by molar mass. And what was the molar mass, once again, from our previous question, is 26.0378 grams per mole of C2H2. What is molar mass? It is the amount of grams per mole, just like that. Now we need to match this unit to this right here. So we're going to say in 1 mole of C2H2, we have 2 mole of hydrogen. Now how did I know that? Through molar ratios and subscript right here. Okay, so we have 2 moles. Now in 1 mole of hydrogen, what's the number of grams? Because we're trying to go from grams. So once again, we're trying to go from moles to grams. So we're going to go this way. We're going to multiply by molar mass. So we multiply by the molar mass, which, according to our periodic table, right here, it is 1.008. So let's write that in. 1.008 grams per mole. Now let's go back in and see if our units actually cancel out. So grams, grams, moles, moles, mole, mole, and grams. Yeah, we want our answer to be in grams, so we got that. And when we go in and actually do all the math, so we multiply the numerator, we multiply the denominator, and then divide the numerator by the denominator, we should get 24.8 8 grams of hydrogen. So with that many grams of hydrogen, sorry, let me speak again. In so many grams of this, we have so many grams of hydrogen. And that is essentially how you use stoichiometry and this diagram to convert from particles to moles to grams, and as well as using mole ratios and doing the railroad method. Make sure that your answers have the correct number of sig figs and proper approximations. And I hope this video helped.